Hello, flying enthusiasts and pilots. Today I want to give you a short presentation about Canard gliders. So I want to speak about first ideas and concepts. So in the agenda I will touch the Wright brothers, of course, who flew the first time, Canard, and then I want to come to Burt Rutan, a genius in design for the very ease. So after that, I would like to introduce you to three different classes of canards and to give you some ideas. And after that, we can come to what comes next and discussion of ideas from experts. So in the beginning, it was 1896. So that's more than 120 years ago. The Wright brothers had a bicycle shop, and they engineered the Canard. They wanted to fly with a motor. That was their task, and they started with gliders in the Canard configuration, and you can see that they had a very clever design, lightweight, with this double-decker. And they were the first to control all three axes, so pitch, yaw, and roll. And that was a very clever idea, and I think that was one big point why they succeeded in the end. The other thing was that they designed their own motor. So they calculated to come up with 8 to 10 horsepower, and you wouldn't imagine how much pounds that would take. It was a goal to have less than 200 pounds for 8 to 10 horsepower. In the end, they succeeded after 7 years with the flyer you see on the lower right side, and they had several flights, but the flyer was not so easy to control, but they succeeded in the end. So then the development went on. Here in Germany, a rocket Canard from 1928 was designed and flew on top of the Wasserkuppe. And the important thing was to start with the rockets, and they had two of them in the fuselage, and in the end the first one was ignited, and then the second was firing the propulsion, and they succeeded to land afterwards not in the valley but on top of the mountain, the Wasserkuppe. Yeah, they were very excited about it and made the second flight, and it was Fritz Stammer, but unfortunately the second rocket caught fire, and he was very lucky and very genius to land this glider, but he could get out of it in time, but then the glider burned down. So the old enthusiasts, they really had to suffer and test the very unknown. So then let's jump to a very modern design from 1975. That was the design of the Very Ease, home built from Burt Rutan. And as you can see, it's a very clean machine with a propulsion propeller and high winglets at the end of the main wing. And you also can see the Canard in front, which is quite long. Has a different design to a conventional elevator. As you can see on the lower left picture, the Canard is around about half of the wingspan, and So it's straight, while the main wing is more backwards, yeah, to give more stability. So the stability comes from the wings and also the winglets, and the canard has to be designed in a very clever way, because you get a downwash on the main wing, and so the canard is important, very important for the whole design, the position of the canard and the airfoil, of course. And as you can see on the picture on the left lower side, you have a front wheel that's retractable, and it has a long plate to have additional drag. Unfortunately, even during the start you have this drag, so you have to retract the wheel very quickly, and the takeoff is quite an important figure to deal with. So here you see the Canard, and it's designed as a split fowler. So especially during the takeoff phase, before rotating, you can produce quite a bit of lift, and then the nose goes up, and you can climb with 85 knots, and the minimum stall speed is around 55 knots. So this is different to other planes, as this is a high-speed plane. You really need quite a bit of speed for rotation. It's the same procedure during the landing. You come in with 100 to 100 knots, and then you flare the whole thing, and you just wait, and when you are sitting on the ground and rolling, the nose drops down by 20 degrees, and you just leave the nose down and brake the whole thing to lower velocities, and after that then you can take up the nose in a neutral position again and brake once again till you come to a standstill. So this is a different procedures starting and landing, but in the air I can tell you, as I'm also a very easy pilot, it's very handy to fly, no heavy control forces, very reluctant, and very nice handling characteristics. Of course, you have to keep your speed, but here you can see a 3-view drawing. This is really a very tiny machine. You have less than 7 meters of wingspan, and you have around about 550 kilograms max weight, and only a motor of 85 horsepower. And the wing area is only 5 square meters, and the Canard adding up with 1.1 square meters. So the total wing area is just a little bit above 6 square meters. And so the wing loading is quite heavy, with 90 kilograms per square meters, and the power at 75%, you reach up to 140 knots. The wind from the side allowed is up to 25 knots, and that's quite high, but you're not permitted to start when it's raining, and no spin is allowed, and you are not allowed to start on grass. Yeah, so there are also some disadvantages, as you can see, but that is because you have these higher speeds, and you can see here the comparison of the two best designs in class, which are similar in the white and similar in the design strategy. So you have the MCR-01, an ultralight, and designed by Michel Colombin, a French pilot. This flew 20 years after the Varieze, and it has, as the airfoil, you have a fowler to come down to low approaching speeds and takeoff speeds of around about 35 knots. And so this is done by a fowler, and once you have the fowler in place within the airfoil, you have a speed airfoil, and you can reach to up to 120 knots. But you see here the Canard has advantage in speed. So